Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between generative AI and discriminative AI. Core function create generative AI creates new data instance that resemble the training data. Discriminative AI classify or predict a label for given data instance learning type. Generative AI models the full distribution of data PXY or PX for model conditional probability or decision boundary, it's a PY. Output type synthesized content, image, text, music, codes, indiscriminative AI, a single label or value, example cat 25.5. Goal to learn underlying structure that governs the input data is, in generative AI. In discriminative AI, to learn the optimal in boundaries that separates different classes or predict a value. Complexity. Generative AI is generally more complex to train and evaluate due to open-ended nature of generation. Discriminative AI generally simpler to train with clear quantifiable metrics, example accuracy MSC. Key architecture. Generative AI GAN, generative adversarial network VAE, variational autoencoder, diffusion models, large language model LLMs, discriminative models, CNN for image classification, RNN for sentiment analysis, SVM, logistic regression, evaluation matrix, generative AI, FID, IS, inception, score, perplexity, human evaluation, discriminative AI, accuracy, precision, recall, F1 score, AUC, RMSC. Example, generative AI, Dell E, Midjourney, ChatGPT, AlphaFold to some extent. Discriminative AI, Google Lens, object identification, email, spam filtering. Moving to question difference between reinforcement learning and supervised learning, data and feedback type. Reinforcement learning rewards signal based on action taken in an environment. Supervised learning label data input output pair the correct answers. Goal reinforcement learning to learn an optimal policy, a sequence of actions to maximize cumulative long-term reward. Supervised learning to learn mapping function from input feature to output label of values. Decision process. Reinforcement learning sequential decision making current action influence future rewards and states. Supervised learning static one time decision prediction is independent of the past prediction. Training data source. Reinforcement learning data is generated by the agent interaction with the environment, trial and error. Supervised learning data is provided externally as a pre-collected static data. Time dependence. Reinforcement learning highly time dependent. History and sequence of states actions are critical. Supervised learning typically time dependent, independent unless dealing with time series data. Exploration. Reinforcement learning requires a balance between exploration, trying new things, and exploitation using the best known strategies. Supervised learning, no need for exploration. Model is purely based on the given training data. Typical algorithm: Q learning, sparse policies, gradient reinforcement, A3C, DQN. In supervised learning, linear regression, logistic regression, decision tree, SVM, simple neural network. Real world example: training autonomous vehicle, game playing, example AlphaGo, resource management. Supervised learning, image recognition, spam filtering, house price prediction. Moving to question difference between online learning and transfer learning. Feature focus, adapting to new incoming data and handling concept drift. Transfer learning, reusing knowledge learned from a source task domain on new target task domain, data types, online learning, streaming data that arrives sequentially over time, transfer learning, static or semi-static data from source domain and target domain, knowledge retention, online learning concerned with retaining old knowledge, avoiding catastrophic forgetting while learning new data, transfer learning concerned with repurposing prior knowledge to speed up learning and improve performance on related task. Model structure, online learning typically the model structure remain fixed, only weight are updated incrementally. Transfer learning often involves modifying the model structure, example freezing early layer, adding new output layers, training efficiency, online learning efficient on the incremental basis, low memory and low compute per update, transfer learning efficient on holistic basis, dramatically reduce the time and data needed to train the target model from scratch, use case online learning, real-time prediction, dynamic system, example, recommendation engine, transfer learning, computer vision, example, using pre-trained ImageNet model, NLP, example, using BERT, GPT, source data needed, in online learning, the model knowledge comes only from the continuous data stream. Transfer learning, the model heavily relies on the knowledge gained from the large source data set. Prerequisite online learning needs a mechanism for efficient, fast, and continuous parameters update. In transfer learning, leads a source task that is related to the target task. Please like, subscribe, and share the channel. Thank you.